In the shop today, we have a 2002 Ford Expedition with a 5.4-liter engine and almost 155,000 miles on it. The owner is complaining of an intermittent misfire when the vehicle is under a heavy load. For example, when he is pulling his boat or when climbing a steep incline. Whenever you are diagnosing a single-cylinder misfire, first thing to do is expose which cylinder has the issue. There are a lot of very effective and creative methods to determine the missing cylinder. But it gets a little more challenging when it is only misfiring under a heavy load. We decided to check for codes first. None were found. We then looked at the misfire counter, and as you can see, even when we were power braking, no consistent misfires are being detected. We then decided to go to Mode 6. Because it is connected directly to the processor, Mode 6 is written in a hexadecimal language. Hexadecimal is a language computers use, and when broken down, it becomes a series of codes of ones and zeros. Mode 6 can also help us to determine if a trouble code is about to set. Let me explain. On this particular Ford, even if you have a capable scan tool, you can use Mode 6 to see the misfire counter. To get the Mode 6 misfires using a modus like this one, go to the generic functions, non-continuous monitors, then go to the test ID $53. This can be confusing because it really is a continuous monitor. Ford thought it was important enough to see misfires, so they put it in here. The $ is just signifying a hexadecimal number. Here you can see the ECU ID and test ID. But are mainly concerned with the component max, value, and result readings. The component reading indicates the cylinder, and as you can see, this is cylinder number 1. The max is really a percentage of misfires which can occur before the check engine light illuminates. The value is a percentage of misfires which have occurred on that cylinder, and the results indicate whether the percentage of misfires has reached a limit to turn the check engine light on. To convert the value into a percentage, on this vehicle, multiply it by 0.00015. For example, the max value is 15,616. Multiplied by 0.0015 equals 2.3%. When the misfire counts go over 2.3%, the check engine light will illuminate. Let's scroll down a little further. As you can see, all the cylinders show 0 misfires until we get to cylinder number 7. Under value, it says 7,724, which is 1.1% misfire on this cylinder. Not enough to turn on the check engine light, but we know there are misfires occurring in cylinder 7 for some reason. This misfire could be occurring because of a compression, fuel, or spark issue. We started with the easiest test, which in this case was spark. We grabbed the trusty spray bottle of water and covered number 7 coil. The misfire started occurring very frequently. We then pulled the coil for a close inspection. We didn't find any holes or cracks in the boot, so we pulled the plug. Look at the gap between the electrodes. We found out later these plugs are original. We replaced the spark plugs along with the number 7 coil, and the misfire was corrected. We took the plugs and the coil to our lab for an evaluation, and here's what they found.
Thanks, Jim. Appreciate the information that you've given us, and especially the fascinating information about the Mode 6 analysis that is available on the scan tool on this particular vehicle. What it has told us is that the driver is right. The car does miss, the counter is seeing this, but it only happens under certain circumstances, and it's not severe enough to set a check engine light. This is called a soft failure. You have to look in this particular case for some set of circumstances that would explain a partial misfire that doesn't happen often enough to set the check engine light, but yet it is severe enough under some operating circumstances for the driver to notice. We took a look first at the spark plug that you gave us. One of the very first things that we noticed is that this spark plug is damaged. When you look at a normal spark plug, what you see is the central electrode with its piece of platinum on the top, designed to work with the ground electrode. The voltage that it takes to fire this spark plug is a direct function of how these particular parts are shaped. You need these sharp edges. You need these sharp edges also to minimize the required voltage to fire the spark plug. In this particular case, what we found is that the platinum tip is mostly missing. And because the platinum tip isn't there to protect the central electrode, what we've got is a central electrode that is badly rounded off. What this results in is growth of the spark plug gap. It also results in the loss of the sharp edges. It'll take more voltage to fire this spark plug. When the required voltage from the spark ignition coil goes up, that puts other parts of the system into play. The rubber boot on the bottom of this particular ignition coil is supposed to give a level of insulation around the output spring that connects the coil to the spark plug. It has to give enough high voltage protection so that the high voltage always jumps across here and not out the side of the boot to tag the engine block. That's what's happening in this case. The required voltage goes up because the gap has grown, and also because now we're putting the engine under heavy load. We're going up that hill, we're putting a heavy boat on it to tow it, we're putting it into circumstances where the engine needs more kV. What's happened here is that instead of the spark jumping across here, it's occasionally jumping sideways out the boot and nailing the engine block. What this engine needs is absolutely a new spark plug. Don't know why it's damaged, but it is. What it also probably needs is at very least a spark plug boot on the ignition coil. Once they're damaged, once you've got that first pinhole through the side of the spark plug boot, then the voltage required to jump through it the second time goes down, and every time this voltage goes up, you'll get a misfire out of the side of the plug. There's your answer.
That's it for today. Thanks, Mike, for the insight. And we'll see you again next time in the Wells Garage.